Hey, this is Horner, and this is the part two of the PlayDoh Lab. In this part of the lab, instead of changing the length, we are going to change the diameter of our Play-Doh. So we'll starting again with the same setup we had before. I'll go ahead and turn on our power source, and we should get somewhere close to 5 volts potential, which we have, and we're going to read the current. So this right now is a 10 centimeter piece lengthwise of Play-Doh, and then the diameter of this Play-Doh is 3 centimeters. At this point, you'll want to record the potential and the current. And now that you have those potential and current values, I'm going to go ahead and I want to take a little bit of the Play-Doh off, and I'm going to change the diameter by just going ahead and I'm going to roll it out so that it becomes the same length. So we want that 10 centimeters again, but because I took some of the length off and roll it, this should give me a smaller diameter. So we probably won't do as many trials with this one as we did with the length, just because we won't have as much Play-Doh left. So I'm going to roll this out just a little bit more, make sure that it is 10 centimeters, and it is. And we're going to check. Let's see what the new diameter is. The new diameter now is about 2.8. So their diameter now is 2.8 centimeters. Let's go ahead and put on the 2 electrodes, and we can measure the new current at this 10 centimeter long length, but a smaller diameter. And there's your new value. So let's go ahead and let's make it a little bit smaller. So we'll take some more clay off, and we'll roll this out again so that it is 10 centimeters. Just keep rolling it, try to keep it as uniform all the way through as possible. So if you think about water, we would be making the pipe thinner. The diameter of the pipe would be smaller. And so let's see how this affects it. This is a little bit too long, so we'll smash it together a little bit, try to get a little bit more uniform. Okay, now we're set. We have 10 centimeter length again, and our diameter this time is somewhere around 2.4 centimeters. So we have 2.4 centimeters, and we'll plug this in. And here is our new current and potential. And we need to do it again. So let's take another piece of Play-Doh off, and we will roll this down again, make it thinner. So we'll roll it out here, get it back to the 10 again. And so it's approximately 10. Try to get a little bit more uniform. And now we can measure the diameter again. Our new diameter is somewhere around 2.4. Yeah, this is about 2.4 centimeters for our new diameter. Still have a length of 10 centimeters. Here's our new current. We'll take a little bit more off, roll it out again, get it back to that 10 centimeters again, and check our new diameter. Okay, so there we go again. We're at 10 centimeters once again, and our new diameter this time is approximately 2 centimeters. So now we're looking at somewhere around 2 centimeters or so. Probably 2.1. Let's call it 2.1 centimeters. And here is our new current. .1 centimeters and a new current. Let's go ahead and pull a little bit more off. We'll make it thinner one more time. So far we've done 1, 2, 3, 4, 5. This will be data point number 6. So get it rolled out. Make sure it is uniform as we can get it. So not an exact lab, but a good lab to kind of see how both length and diameter, or cross-sectional area, will affect the resistance in a wire, namely PlayDoh here. We are now down to, looks like it's about let's call this one 1.9. 1.9 centimeters. And here are our new values. We'll go ahead and take a little bit more off, and we will roll it again. Get that 10 centimeters. All right, so we're back at 10 centimeters again. We have a new diameter. This diameter is about 1.6 centimeters. We will take a new reading. So we've gone down again. And let's do it one more time. So that will be 1, 2, 3, 4, 5, 6, 7. This should be data point number 8, I think. Hopefully that's correct. We'll roll this out, try to get it as uniform as we can. And that is a little bit longer than 10. There we go. Now we're right at 10, and our average diameter here is about 1.5 centimeters. 1.5 centimeters. So we'll plug this in and see what we get. There's our new value. And so now you should have all the data that you need for the lab. And that is the end of part 2.